Okay, question number 21. All right, so this is, I think, a trickier problem, so let's go ahead and take a look. In most freshwater fish, nitrogenous waste is primarily excreted as ammonia, which is highly soluble in water and is toxic at low concentrations. In terrestrial mammals, ammonia is converted to urea before it is excreted. Again, urea is kind of like what's in urine. Urea is also highly soluble in water, but is less toxic than ammonia at low concentrations. Which of the following best explains why freshwater fish do not convert ammonia to urea for excretion? All right, this is an interesting question because why do fish not convert it to urea if it would be theoretically safer for them? Let's take a look at the answer choices. So the first one says, the metabolic pathways of fish do not normally involve nitrogen consumption. Now notice that nitrogen is not ammonia, right? You can get nitrogen from other sources. And again, if nitrogen is toxic, then it's probably not going to come from, or excuse me, if ammonia is toxic, then, well, actually, sorry, let me back it up a step further. They're still going to need to undergo, or they're going to need to make use of nucleotides, which contain nitrogen. So they'll need to get their nitrogen from somewhere. So this one's out. And again, we're trying to figure out why do they not convert ammonia to urea. And this is just kind of irrelevant because they do need nitrogen. So anyway, answer choice B says the dilution of ammonia by direct excretion into fresh water conserves energy. Okay, well, I mean, yeah, if you're skipping a step, so if you just basically spit out the ammonia, this is what ammonia is, instead of converting it into something like urea, well then yeah, this is potentially less energy, right? So that could explain it. But let's look at the other ones first. Ammonia is concentrated in tissues where it is stored prior to excretion. But remember, they just said that ammonia is toxic at low concentrations, right? So if we're storing it in our tissues and it's toxic, that doesn't really make too much sense, unless there is some specialized storage unit for it in fish. But again, that I think you have to assume a lot there. Now, for answer choice D, it says the nitrogen in ammonia is recycled for use in protein and nucleotide synthesis. Well, again, if that were the case, then, I mean, you would hope that there would be a lot of ammonia circulating so that they would have enough nitrogen to make use of nucleotides which contain nitrogen in them, right? Or I should say, which contain nitrogenous bases. So, but again, we see that even at low concentrations, it's still toxic. So D doesn't make sense. So therefore, the correct answer is B. We're going to hope that this energy conservation is a greater benefit to them than the fact that they're excreting small amounts of ammonia. We're going to hope that that small amount is negligible in the long run. But anyway, the correct answer is B. If you have any questions, feel free to comment below, and I'll see you in the next video.